My 11th standard warriors, welcome to the backlog series for all the important chapters before you move to the 12th grade, because we have set really high expectations and I really want you guys to crack JEE 2023, and this is what it needs to make sure that each and every topic which probably you have left because of some or the other reason, let's try to boost your understanding, and then you can watch the detailed classes which is there in the nurture playlist. So today we are going to do a one-shot revision and cover your backlogs of all the important topics in oscillations. Hello, welcome Ramesh, Srikanth, hi Aishwarya, hi Avipsa Das, hi Shubham. Good evening, happy Setu, nice to see you all, happy faces. I read all your comments, and guys, thank you so much for all the lovely comments that you posted on my yesterday night's video. It means a lot, and you know, I really wanted to do this from a long time. I was not finding time, but now I am going to make sure that your 11th revision of all the important topics is going to be done. So let's start. And those of you who do not know me, my name is Shreyas and I'm the physics master teacher leading the JEE division at Vedantu. So you know, I have been training for a very long time now, and now the ball is in your court. So we have to work on this together, guys. Hi Shubham Samal, hi Srikanth, hello Rashi, hello Varun. I'm very good, and I'm all excited because you guys have had a lot of tough times in the last few weeks and months because you had your college exams. Most of your college exams are done. Yeah, is it done? Let me know. And now it's time to actually move on to 12th. The 12th standard courses will start towards the first week of April or something like that. I'll let you know all the details, but for now let's complete our 11th standard topics. And I know that there are certain topics which are very important in 12th which you should learn in 11th, like for example simple harmonic motion, waves, gravitation, rotation, Newton's laws. These are very important chapters which are going to be used in 12th. So I'm going to do all those topics because then you will not feel uncomfortable in your 12th grade. Okay, let's begin. And if you have not yet smashed the like button or hit the subscribe button, go ahead, do that now, because that's how you subscribe to our channel. And the reason why I want to show you this slide where I showcase all the amazing results which were produced by Vedantu in JEE Mains, Advanced, Boards, CETs, every other examination, is because this is something which you should have in your mind, because we are going to break the record next year. Even this year, your seniors are going to break it. So you have to break the record next year in JEE 2023. So let's begin with the equations of SHM and what a simple harmonic motion is. All right, very good Anish. Yes Mansi, good evening bacha. JEE 2023, yes, you will get bacha. Don't worry, have some patience, you will definitely get it. Now, let's start with what SHM is and all of that. So, okay, just let me get my pointer over here. Okay, did I have it? Okay, there I go. All right. Now, imagine any kind of oscillation which is periodic in nature. That periodic oscillatory motion is what you study in this chapter. So when I talk about simple harmonic motion, these are nothing but your periodic. You know what is periodic motion? The motion which repeats itself. And oscillatory means to and fro. Periodic oscillatory motion, and which can be expressed in a single sine or cosine term. So just to show you how the oscillation looks like and what are the different terms involved in an oscillation. So imagine a particle going back and forth, something like this. This point where, you know, it has maximum velocity, or which is the midpoint of the two end points, that is often called as the mean position. This is the mean position, sometimes also referred to as the origin. The particle goes like that, stops over here. This is called as your extreme position. You can also call it as the extreme right. It stops, comes back, achieves a very high speed, and again stops over here. So this is your extreme left point. This is your extreme left point. It stops, turns around, and again increases the speed and stops. It oscillates back and forth. Very, very important things. The distance from one mean to this extreme, that is called as the amplitude of the oscillation. This is A. Even obviously this is also amplitude A. The time taken to cover one oscillation. So the time taken to cover one oscillation. So if I start from here, I complete one oscillation. So the time taken to cover one oscillation is called as the time period, and the symbol for that is nothing but T, which is also 1 by F, where F is nothing but your frequency in hertz. Right? These are the important terms. Yep. Yes, Adriti Niranjan, this is what amplitude is. I will be coming to phasor diagrams, phase constant, initial phase. I know those terms are very confusing. I'm going to explain that to you. Don't worry, bacha. I know you find it difficult to understand phase and phasor diagrams. Hello, Ashok Kumar. Yeah. Okay, everyone fine till this point? Cool. Next thing, what is important is something called as your angular frequency of the SHM. How quickly it is completing one oscillation. Usually in case of simple harmonic motions, okay, one oscillation in a phasor diagram, I'll come to phasor diagram in a bit. For now, just assume one oscillation is like one revolution, and one revolution is how much? 2 pi radians. 2 pi radians. So we define something called as the angular frequency, because radians is an angle. So angular frequency is how many angles radians wise you cover per second. Angular frequency omega is nothing but 2 pi radians you take 2 pi radians, you cover 2 pi radians in one time period. So radians per second. So this is your radians per second, which can also write it as 2 pi f. That's your angular frequency, right? Great. Now, the current position of the particle could be anywhere as it is oscillating. Right now that particle is over here. So it has a displacement from the mean position given by x. So what is x? X is the displacement from the position. This is your particle. This x will be a periodic function, and it will be a function of time. And that function has to be a single sine or a cosine term. Now, the term which it looks like is something like this. X is amplitude sine. I'll come to that phi later on. But for now, just remember there is one constant. I will talk about it in detail after some time. For now, realize that the function, the position's function as a function of time is periodic in nature. Be it sine function or cosine function, both are periodic functions and they repeat itself and they are continuous in nature. So it looks something like this, a sine omega t plus phi. And if you look at it graphically, it looks something like this. If this is x and this is time, then you will see that the value of x goes up and down like this. So the x value, observe this x, it increases, decreases on the negative side, and then again comes back, again increases, again decreases. So as this value of x increases, decreases, becomes negative, again comes to 0, you can see the graph goes up and down over here, right? Does it make sense to all of you, my warriors? Okay, so if I show you these terms on the graph, this is not the wavelength. A lot of people get confused, this is wavelength. No, this is one time period, and yes, this thing over here, this is your amplitude. Okay, this is your amplitude. Everybody fine? Okay, I'll be telling you all the details, Kajal, don't worry. Very soon as everything is decided. Yes, just came from school, very good. Very good, nice timing, I would say. Okay, fair enough. Now, I have a question to you. What happens if I add one more term over here? One more term over here. Let's say some C, constant. Does it still remain a SHM? The answer is yes. When I add a C, it just means that the graph gets shifted up. It still oscillates. It's like shifting the origin. You are seeing a particle oscillating about the origin over here. If you add a C, the particle is oscillating here, origin is here. does not mean it is not a SHM, it is still a SHM. So adding a constant does not affect it in any way. It is still going to be a periodic SHM, okay? Don't have to worry about it. So this constant, even if it is there, it doesn't really matter. So it just mentions the shift of the mean with respect to your origin. So sometimes origin and the mean both can be two different points. That's possible, right? Okay. So these are your notes. By the way, the entire notes will be available to you in the PDF form in the Telegram channel. Link is there in the description box if you have not joined it yet. Okay. Now, some more things which you should know. Like I just told you, the position x is a sine or cosine, and you have omega t over here. Like I said, I will tell you about phi in a bit. Hold on for that. You can find velocity by differentiating it. Velocity, which is dx by dt, when you differentiate, what do you get? A omega cos omega t. Similarly, acceleration is rate of change of velocity. So what will it be? Minus a omega square sine of omega t. If you notice all these functions, these are all positions, velocities, accelerations, all these are functions with respect to time, correct? Similarly, you can also write it in terms of x. That is possible. You can rearrange, use some basic trigonometric identities. I've done a detailed derivation on YouTube in the nurture playlist. If you want, you can check it out. But for now, how do you convert these variables in terms of positions? This is the formula. Velocity is omega root a square minus x square, and acceleration is minus omega square x. These are basically your functions in terms of x. This is also valid. Very, very important. Everybody clear? Very good. Now, having said this, let's do some questions based on this theory. Here's your, oh, by the way, before that, if you notice over here, this particular thing, this is your maximum speed. This is your maximum speed. And this thing over here, this is your max magnitude of the acceleration. So this is a max acceleration. Where do you think the speed is maximum? Where is the speed maximum in a SHM? Try to think about it. When you have a SHM like this, this is your mean, this is your extreme right, this is your extreme left. Where do you think the speed is maximum? The speed is maximum at the mean position. So this is at the mean position. You can try this out. If velocity has to be maximum, this term has to be maximum. That means whatever you are subtracting should be least. You are doing minus x square. So x should be 0. Similarly, if you want maximum acceleration, x should be as large as possible, and this will happen at the extreme position. So both the extremes, the acceleration is maximum when x is equal to a. Very good, excellent, Aisha, Riyaz, Jisno, Simran, Aisha, Avipsa, Ramalingam. Very good. I am very good, Nikki. Very good. All right. Here comes the question on your screen. A particle executing SHM has maximum speed 30, maximum acceleration 60 centimeters per second square. Find the time period of oscillation. Come on, let's see how many of you can do this. Just know, we do not have ISC coaching, but we have CBSE boards because ISC is a very small number of students. Usually what students do is they prepare for JEE. So all my students who are right now in ISC boards, they are basically studying and preparing for their regular JEE, and it helps them in ISC. ISC board is obviously a little bit more difficult and a little bit more trickier than the CBSE board. So the JEE syllabus helps them, the JEE preparation helps them in ISC board. So that's what people do. Or else you will have to join many classes, this class, that class, it becomes crazy. Hello Anam, hello Shiva. Okay, Riya saying A, Jisno saying A. Come on my warriors. Okay, so the question is simple. You have to find the time period, maximum speeds and maximum acceleration is given. Let's see what is given. Let's write it down. Maybe I will get something. Vmax is 30. Is there a formula which I know for Vmax? Yes. Maximum speed is A omega. So A omega is basically 30. Maximum acceleration is 60. So A max is 60. And if you notice over here, maximum acceleration is A omega square. So going ahead, so this will be A omega square is nothing but 60. Now you know what to do next. Take these two and basically divide. If you divide both of them, it will become A omega square by A omega. A omega square by A omega will be nothing but 60 by 30. So omega will be 2, but omega is 2 pi by time period. So this will be 2 pi by t, which is equal to 2. So time period will be nothing but pi seconds. And do I have some answer over there? Yes, many of you are correct. I am really proud of you. You should give a pat on your back. Well, good. Excellent. Moving on to the next question coming up on your screen now. Very good, Selva. Very good, Reshma. Very good, Simran. Very good. Nandini, we will take around 2 hours. Yep, because it's a one shot, big topic, important topic. So around 1.5 to 2 hours. Are you guys with me? Okay. Oh my God, Anam. I'm so sorry, bacha. I have to buy black shorts or yeah. Thank you for reminding me. Now please, let's not concentrate on my shots, okay? Now I'll become very conscious. I'll have to stick to the wall so that the reflection does not fall on the board. Okay, let's do this. Maximum velocity in the SHM is Vm. The average velocity from one extreme to the other extreme will be how much? Let's see. Okay, let's draw the SHM. Analyze. See, if you guys are finding SHM difficult, always try to draw. And always in SHM, you should start with this. Mean, extreme, extreme. Okay. What is given in the question? The average velocity during the motion from one extreme to the other extreme is how much? Acha, average velocity. Average velocity, do I know the formula for that? Average velocity? Yes, the average velocity formula is nothing but your displacement divided by the time, the total displacement upon total time. From here to here, what's the displacement? This is A, and obviously this is also A. Displacement is nothing but 2 times of A. From here to here, how much time do you take? Okay, think carefully. If you start here, go like this, come back over here, that is one oscillation. Like this and like this. But just this, that's half the oscillation. Half completes the one oscillation. So you are going to take time of t by 2, right? So here, I think this will now become 4a by t, but I don't have to give the answer in terms of time period. I have to give the answer in terms of maximum speed. Now notice over here, maximum speed is Vm. So Vm, maximum speed is a omega, k, and omega is nothing but 2 pi by t. Very good. So time period will be, time period, take the t over here, bring that Vm down, a into 2 pi divided by Vm. So once I know this, substitute the value of t over here and see what you guys get. You will get this as 4a by time period, that means a into 2 pi divided by Vm, which means 2 goes, a goes, so you will have Vm 2 and divided by pi. So is that option there? A lot of you are saying option A. Oops, no, it is option B. You guys made some mistake. It's 2 Vm by pi. I think you made some mistake with that calculation. Hi Vandana, welcome aboard. Okay, understood. Daksh, you got a wrong answer and you're telling me to do fast. I think you should slow down a bit. How t by 2, Shubham? Because it's going from this side to this side. If it is going from this side to this side, that means it is half oscillation. This is half oscillation and this is another half of the oscillation. One oscillation is how much? Time is t. So for half oscillation, time will be t by 2. Make sense? Okay. No, we are not going to do complex harmonic motion, but we'll see combination of SHMs. Okay, so we are seeing combination of SHMs in this lecture too. Okay. Okay, Naresh, I started with the concepts at the beginning. I'm not sure if you missed the starting part. We just did the revision of the formulas. I told you all these terms. So I'm going to teach you concepts, problems. Concepts, problems. The entire chapter will be covered like this. So right now we are only doing problems on whatever topics I've just taught you. All right? Yes, even if you are a NEET aspirant, you can still watch it. Okay, moving on to the next question. Okay, let's go ahead. displacement graph is given, the corresponding force graph is. And remember guys, very important for JEE, especially physics, if you are preparing for JEE, the preparation is very different than what you do in boards. In boards, you do NCERT underline, you memorize the definition, you go to the back exercise, write the theory. In school, they will make you practice the same thing again and again. No, JEE preparation is completely different. So I'm not sure if you have seen how students prepare for JEE. So guys, it's very important to solve problems and understand theory. You have to know the theory basics and then solve problems. Only then you get a firm grip on the concepts. Okay. All right, Daksh, no problem. Come on, try to solve this. Displacement graph is given. Find the graph corresponding to force versus time. Let's do this. Muthu has lit up the chat box. Very good. Here, if displacement graph is given, you can see this is a sine curve. So that means x is basically a sine omega t. A sine omega t. And force, that's mass into acceleration. Force is mass into acceleration. And acceleration, we know, is nothing but minus a omega square sine omega t. That means there is a minus sine omega t term, and yes, you have certain constants like ma omega square. So minus sign, flip the graph. The opposite of that graph will be option B, I suppose. This is minus sign. This is minus sign. It is B. Yes, yes, it is B. SHM. Oh my God, Daksh. Please watch my big lectures or the detailed lectures of SHM, simple harmonic motion. So I have covered that in a detailed series. I have spent almost like 8 to 10 hours on that. Please watch that, bacha, okay? Because you're in 10th, right? That's why. Most of the students here are in 11th standard, so they already have certain idea of what SHM, Newton's laws, and all of those things are. So if you're in 10th, obviously you're going to find it difficult because this is one of the last few chapters in the 11th standard. Okay, moving on to the next one. Yes, it is for JEE only, bacha. How flipping displacement becomes force, Muthu? Because look over here. Look over here. This is force graph. Don't you see the minus sign term? Don't you see the minus sign term? Constant is there. What will that constant do? It will elongate it. That's okay. But minus sign, if sign is like this, if this is sign, minus sign will be obviously like this. That's all. So nature of the graph is important. Making sense, Muthu? Hi, Deepak. Okay, very good. I hope this is clear, bachalo. We will solve the next question. A simple harmonic motion has amplitude A. Time period is T. How much time do they require to go from A to A by 2? Interesting. How much time does it take to go from A to A by 2? Let's solve this question. First of all, let's draw it, because only when you draw it, you will get the idea. Okay. This is your mean. This is your extreme right. This is your extreme left. Now, think it's mentioned in the question that you have to go from x is A to x is A by 2. That means you have to start from here. This is where you need to start. And the end is over here. The end is over here. You have to go like this. And this is obviously at A by 2. And this is at A. This is at A. Now, there could be many thoughts that are coming in your mind. How do we start the question? I feel we should start with first writing down the equation of SHM. Now, see, there are many ways of solving the question. One of the ways is, well, just mathematics, and I'll tell you how. If I write the equation x is equal to a sine omega t, that means the graph will look like this. That means at t is equal to 0, x is at t is equal to 0, sine 0 is 0, x is 0. You start at the origin. That's what this equation means. But if I write the equation x is equal to a cos omega t, that means the graph will look like this, because cos graph starts from maximum value, and at t is equal to 0, x times 0, cos 0 is 1, x is nothing but a. This is very, very interesting. So when do you use sine function? Preferably when the particle starts from the mean, then it becomes easier to use sine functions. But if the particle is already at extreme, if the particle is already at the extreme situation or extreme position, then use the cos function. This is when it is at the mean position. Now it becomes very easy. So use this function and let's try and solve the entire question. So at t is equal to 0, x value is a, at how much time is the particle here? That's it. Since x is a, sorry, not sine, my bad, cos, x is nothing but a cos of omega t, the choice of the function is very crucial for solving the question. All this knowledge should be there. You are not going to write all these steps. This is all there at the back of your head. You should know, oh, mean, sine, extreme, cos. It helps you solve the problem in a much faster way. When the time is t, the value of x is a by 2. A goes, so half is equal to cos omega t. Whose cos is half? Pi by 3, which is 60 degrees. Cos 60 is half. So omega t is basically 60, which is nothing but pi by 3. But the question is to find the time, right? Okay, omega is nothing but 2 pi by t into t is equal to pi by 3. So naturally t will be equal to, check this out, it will be t by 6. And do I have t by 6 somewhere? Yes, option A, I suppose. Yep, option A is correct. Did you understand what we did in the question? Because it had already started here, I preferred using the cos function. If the question said from x is equal to 0 to a by 2, from here to here, then I will solve the question using sine function. That's the magic. Got it, my bachcha log? Very good, very good, very good. Let's move ahead to the next concept. Okay, now comes phasors. This is also very, very crucial. So what is phasor? Why is it so talked about? And phasors are so important that without this, you will not understand superposition, nor will you be able to apply it in waves and light waves in 12th standard. So let's talk about it. See, imagine that you have a simple harmonic motion, something like this. This is your simple harmonic motion. This is your mean position. This is your amplitude over here. This is your extreme right, and this is your extreme left. Now, I want to create a scenario which resembles the simple harmonic motion. This is your simple harmonic motion, which will be helpful for solving problems in many cases. Imagine a hypothetical concept. It's not real, but it's a hypothetical concept which enables us to solve simple harmonic problems. Reason, in a simple harmonic motion, the speed is decreasing, stops, increasing, stops, position is varying, and it is not uniform velocity. Acceleration is also changing. It sometimes becomes difficult to analyze. But circular motion, uniform circular motion, that's very easy to analyze. And using the concepts of uniform circular motion, you can solve many questions of simple harmonic motion. So, let's see. Good evening, Apurva. Hello, Seema Bacha. Welcome aboard. Nauro, why not t by 4? Because cos 60 was half, and if you solve it, you get it as pi by 3, and when you rearrange, you get it as t by 6. That's why. Like, use the math, Nauro. You will get the answer. Comet K is obviously much simpler, Rohan, than J. Now, what I do is I draw a circular motion. So let's say this is a big circle. I'll try to draw the circle as perfect as possible. Okay, and this is my reference line. This is my reference line. And this is my another horizontal line. This I will be calling my x-axis. Now, the concept of shadow comes over here, or projection. See, tell me one thing. If there are rays of light like this, if you have a cylinder and this is your screen, how will the shadow on the screen look like? how will the shadow on the screen look like if you have a cylinder on its way? Come on, put up the answers in the chat box. I want to know, how will the shadow of a cylinder on the screen look like? Come on, my warriors. Definitely Avipisadas. It will obviously look like a, what will it look like? It will obviously look like a rectangle, correct? It will look like a rectangle. Everybody understands this? Okay, perfecto. Similarly, imagine if you have rays of light coming in like this, but you have a tilted circle. If you have a tilted disc, then on the screen, how will it look like? It will look like an ellipse, right? Like an oval. It will look like ellipse. So this is called as the idea of projection or shadow. This is very important. I'll tell you why. See, imagine, I tell you, the rays of light are going like this. The rays of light are going like this. And imagine that there is a particle which is performing uniform circular motion. It is going round and round. Okay, it is performing uniform circular motion. Now imagine I give you a screen over here. How will the shadow of such a particle which is performing uniform circular motion look like? Look over here. The shadow will be formed right over here. This will be the shadow, right? As this point P moves, this shadow will also move. Do you see some interesting thing which is happening over here? The shadow goes only in this range. Is it not going to and fro? Is it not performing a simple harmonic motion? Can you see that? It is not performing a simple harmonic motion. So this is the shadow or the projection. Now, the same concept is used over here. I'm going to draw a uniform circular motion. The shadow, the rays of light will come here. It will make its shadow either here or here, wherever. And that point or the shadow point will perform simple harmonic motion. Got it? Perfecto. So this over here is nothing but your uniform circular motion. So I will say the projection of uniform circular motion is nothing but your simple harmonic motion. Now there are few things that you need to draw and keep in mind. Okay, observe this. Let's say, for example, initially my particle which is performing uniform circular motion is over here at t is equal to 0. So I will draw a line over here, and this is the radius. The radius is a. So in the uniform circular motion, the radius of that circle is a. At time 0, it makes a certain angle phi with respect to the reference. That I'm going to call it as the initial angular position. Initial angular position with respect to the reference, I'm going to call it as phi. Fair enough? Okay. Now, after some time, what will it do? After some time, this point will come over here because it is revolving in a uniform circular manner. So definitely it will have some angular speed, omega. So I'm going to mention over here angular speed. The angular speed is omega. And if you wait for certain time, this particle will come somewhere over here. This is at time t is equal to t. How much angle will it cover? Angle covered will be speed into time. Speed into time, omega t. Fair enough? Everybody clear about this? Yes, you can definitely, Mr. Innocent. This is a one-shot revision of 11th standard topic of SHM. Anthony, you can definitely go a little bit behind and catch up. Very good, astronaut. Hello, JEE Enthuse. Okay, now imagine I project the rays like this. Where will the shadow form for this point? The shadow will be formed over here. This is that particle P at any instant t. In fact, the way to look at that is by just dropping a perpendicular over here. Just drop a perpendicular over here. This length is exactly this length. This length is exactly this length. As this point moves, that particle also will move on that yellow line. So if I just drop a perpendicular, I will get where that point P is. And yes, if this is phi, this is omega t, how much will this entire angle be? If this is phi plus omega t, this angle, these are two parallel lines, this is a line, obviously it will be phi plus omega t, and this is your horizontal distance, which is nothing but x. So this is your hypotenuse, this is phi plus omega t. What will x be equal to? It will be a sine omega t plus phi, sine component. As simple as that. Very good, Ninja. I'm so glad your tattva arrived. Now, don't you see, this particle is just performing uniform circular motion. The x component is performing simple harmonic motion, exactly what we wanted. If I ask you what is phi plus omega t, in terms of circular motion, this is the total angle at any time. That angle will keep on changing. It's the current angular position. It's the current angular position. That's what it resembles. Now, if you notice and compare all the terms, now you will understand what each of these terms in circular motion means in simple harmonic motion. In simple harmonic motion, this radius of the circle now becomes your amplitude, correct? It becomes your amplitude. This initial angular position, phi, is now called as the initial phase angle, because this term is called as just phase angle. This is called as phase angle because this is phi plus omega t. If you put time as 0, you will just get phi because omega t will vanish. That's why that word initial means t is equal to 0. Fair enough? And angular speed over here is now called as angular frequency. It's called as angular frequency. Now, what does phi actually tell you? It's very simple. Phi tells you at time 0, where are you? At time 0, where are you? Basically, if I extend it further over here, this is where the particle was initially. This is your initial position in SHM. So if you substitute time is equal to 0 in this, the value of x that you will get is the initial position of that particle. That means you will get x naught is equal to a sine omega t 0 plus phi. That means sine of phi will be x naught divided by a. So the value of phi tells me what is the initial situation, what is the initial condition. So guys, help me with this. Let's see if you guys have understood it. Imagine there is a particle which is performing SHM. If I tell you the particle is here and moving towards your right side, tell me what should be the value of phi? Visualize. If the particle is here and going towards your right side, where should this circular motion be? The circular motion should be here and going this side, because only when the circular motion goes this side, this point will go here. So what should be the initial value? Phi will be 0. Everybody with me? Yes, Anthony, I remember you from yesterday, bacha. Yes, everybody with me? Similarly, if I tell you the particle is performing SHM and the particle happens to be at the rightmost extreme, then the particle which is performing circular motion, that particle will be here. If that particle is here, only then you will see that it resembles. Look at this. The particle is here. It is going to move this side. So that means visualize, simulate it, play it, animate it. So then this circular motion should go like this. Only then the shadow will come like that with it. Hence, the value of phi will be 90 degrees. It will be 90 degrees. That's how it works. That's how the situation is. Everybody clear about this? Can we move ahead? Okay, this is phase angle, phase constant or initial phase angle, angular frequency, and all of that. Now, this diagram that you are seeing, this diagram is called as your phasor diagram. This whole diagram for the uniform circular motion, this is called as the phasor diagram, because you can see we are talking a lot about phase, initial phase. It tells you where it is. Phase means where. Which phase are you in? I'm in a very sad phase of life. I'm very happy phase of life. It tells you the situation. So phasor diagram means situational diagram. It tells you where it is in a very simplified manner. Visualization becomes very easy. This thing which is rotating is called as the phasor. The thing which rotates, that is called as the phasor. This is the phasor diagram. Very good. So what's your phase, guys? Are you happy phase, sad phase? Please let me know. Excited phase, nervous phase. What is your phasor diagram? Can you explain why t is equal to 0? Anthony, initial. Initial means what? Initial. Right in the beginning. That means the start of the watch. T is equal to 0. So often it is given, okay, this is SHM. Initially it was moving this way in this direction and it was here. So whenever those initial conditions are given, you will put t is equal to 0, right? Makes sense? Okay, what are your phases? Excited, happy, Rafi also putting smiles. Moderate phase, warrior phase, happy phase, finally will be 90. Yes, it will, the phase will keep on changing. 90, 180, 270, 360. 360 is same as 0. 90, 180, 270 and 360. Yes. Motivation phase. I'm so glad. I'm so happy, guys. You guys are in at least the good phases. Hello, Apurva. So at mean position, phase angle is 0. Noro, I'll give you one important advice over here. Not necessary. What if it is at mean but going this side? Just think, if the particle performing SHM is here but it is going this side. So if you assume in the circular motion diagram or the phasor diagram the particle is here, what will happen? The particle will go like this, but the particle in SHM is going that way. It doesn't make sense. How can the particle go here? Shadow also has to go there. That means the only option left is this phasor has now returned over here. Now the shadow will exactly fall here. The shadow will fall here, and as this phasor rotates, so you will see the shadow will also go this side. So if the particle is at the mean, then there are two possibilities. One, it is 0 or it is 180. If it is going this side, it's 0. If it is going that side, it is 180. Does that make sense? I'm so glad, Anish. Phase has changed. Very good. Now, let's talk about phase difference. So the difference of the situation is called phase difference. You are in moderate phase, somebody is in happy phase. One is in sad phase, one is in very excited phase. The difference of the two situations is called phase difference. Example, imagine there is SHM1. This is SHM1 and there is a particle P1 going, let's say, this way. And there is SHM2, second SHM, two particles going back and forth. These are like two worried pandus. Imagine this is a pandu, guys. Imagine this is a pandu, that's all. This is Chotu Pandu. He's very worried. He doesn't know how to tackle so much of exam pressure. This is Pandu 1. There is another Pandu over here. Maybe he is like this. This is Pandu 2. He is also worried. Both of them are going back and forth, back and forth. So this Pandu goes like this Pandu goes like this. They are performing SHMs. There is a situational difference, phase difference. Both are not at the same point at the same time. So if you draw the phasor diagram, it will look something like this, right? If this is the phasor diagram, this Pandu is here going this side, most likely this is where his phasor will be, so that the shadow falls over here. Third quadrant. Only then, as the phasor rotates, this point will go like this, come back over here and come over here. Make sense? Similarly, for Pandu 1, how will the phasor diagram look like? Pandu is here going right side, most likely the phasor will be somewhere here, so that the shadow falls over here. So as the phasor rotates, you will see this particle goes like that and comes over here. Makes sense? So don't you see both these arrow marks rotate, but they have an angular difference between them. So that is called as the phase difference. So basically your phase difference, the symbol is del phi, is nothing but phi 1 minus phi 2. Keep this in mind, phi 1 minus phi 2. Very good, Simran. Be in the happy phase, bacha log. And anytime you guys go into the bad phase, sad phase, nervous phase, remember Shreyas sir is always with you and he is going to change your phase. And remember one more thing over here, if del phi is 0, both are going together. Both the arrow marks, both the phasors are going together. They are said to be in the phase. And if del phi is a pi radian, that means both are opposite to each other. That means they are said to be out of phase. Like Pandu 1 going this side, Pandu 2 is going this side. Both are going opposite. That's out of phase. Yes. Can it be in the opposite quadrant? Not necessary. It could be in the same quadrant also. Imagine two phasors, one here, one here. What is the phase difference? This is the phase difference. Both are in the same quadrant. If you see the shadows are here and here. So the particles are going like this. Correct? Cool? Fair enough? Alright, let's start with some questions coming up on your screen now. The figure shows the circular motion of a particle which is at the topmost point here on the y-axis. The radius is b, sense of revolution is clockwise, time period is indicated in the figure, SHM of the x projection of the radius vector. Let's see how many of you do this. Jisno, pi phase difference, why is it pi opposite? I'll just explain. See, bacha. Where is it? Yeah. See, imagine one phasor is here. Okay, one phasor is here. Okay, just one phasor is here. Where will the shadow be? The shadow will be here. Okay, this is phasor 1. Okay. Now imagine the other phasor. Is here. The shadow will be here. This is for the second particle. Can you measure the angle between them? What is the angle? 180 degrees, which is nothing but pi radians, right? So what will happen? They both are exactly opposite each other. So this particle is going this way, this particle is going that way. So because both of them rotate like this, right? So this particle will go this way, this particle is going this way. So they'll be opposite. That's why out of phase. Is that okay? Just no bacha? Understood? Okay, out. In means together. Okay, cool. Ramalingam saying A, Anthony also saying A. Well, the correct answer is indeed A. Very good. And I'll tell you why. See, just draw it after some time. You'll get the answer. After some time, the phasor will be somewhere over here. This is t is equal to 0. Obviously, this will be omega t. But we don't want just the position. We also want the projection. So the projection will be on the x-axis. So just draw the projection. This is your x projection. If this is omega t, obviously this is also omega t. So what will be x in this situation? Remember the length of the phasor. It is clearly mentioned. It is b. This is b, the radius. So hence the value of x will be b hypotenuse sine omega t. Now omega is nothing but 2 pi by time period. So it will be 2 pi divided by time period is nothing but 30. So is it there? Yes, option A, of course. You can see that very easily. Very good. Yep. Angular frequency is t into 2 pi. T is the time period. Yeah, okay. Yes. 2 pi by t, not t into 2 pi. 2 pi by t. Okay. Moving on to the next question. Oops. Yeah. Thank God. This is fine. If a body in uniform circular motion covers the given angle in 0.5 second, what is the time period of the projection on the x-axis undergoing SHM? Assume it moves anti-clockwise. Okay, fair enough. No issues. This time it is moving anti-clockwise, so it is going like this. The projection will be over here. This will be the projection, correct? So the question is, this projection, this is performing simple harmonic motion. The particle which is going around the circle, that is performing uniform circular motion. We know the shadow always performs SHM. Remember one thing, the question says, what is the time period of the projection on the x-axis? The time period of the projection is nothing but time period of SHM. The time period of SHM is also the time period of the uniform circular motion, because once it completes one complete revolution, our particle also has performed one complete oscillation. Makes sense? So what is the time period of UCM? Think. 45 degrees, it takes 0.5 seconds. For 45 degrees, it takes 0.5 seconds. One revolution is how many degrees? 360 degrees, correct? 360 degrees will take how much time? 45 takes 0.5, 360 takes how much? 10 biscuits cost 5 rupees. These many biscuits cost how much? Come on, it will be 0.5 into 8, which is 4 seconds. And is it there? Option A, done. Yes, correcto. Excelente. Very good. Amazing go. Let's move ahead to the next question coming up on your screen. Now, you guys are getting hang of it. Very good, Aisha. Very good, Hari. Very good, Jisnu. Nauro. Simran. Yes, Aishwarya. Next question is, the ball tied to the end of a string of length 10 centimeters is rotated with constant speed of 2 meters per second about the origin. Find the equation of the projection of the ball on the x-axis times 0. Ball makes 45 degrees with the x-axis and is traveling in the anti-clockwise direction. Let's visualize. Don't apply just formulas. Visualize. You have to visualize. Okay. So a ball which is tied 10 centimeters, radius is given, speed is given. Okay, I think I should start with uniform circular motion. Oops, my circles are not great. I need a object recognition software. Okay, fair enough. Decent. Okay, guys, my chapatis are never so good. You know, my omelets are also not so round. And most of the times it happens that whenever I try to cook omelets, it always becomes egg bhurji every time. Never. I think only the first time probably I got the omelet right. So it's very difficult. I don't know how many of you have tried making omelets and you always end up getting bhurjis. Anyways, let's try this out. Okay, so it makes 45 degrees with the x-axis. So 45 degrees with the x-axis means here. It is going anti-clockwise. That means here. This is 45 degrees. And you have to find the projection on the x-axis. Projection on the x-axis. This is your projection. This is x. Okay, cool. And you got your hand burnt. Anthony also agrees with me. So after some time, what will happen? This point will be here. This point will be here, and it will be going like this, because this will be omega t. If this is 45, this is omega t. So, and if this is the amplitude, so what will x be equal to in this right angled triangle? X will be the cos component of the hypotenuse. So hypotenuse cos component, correct? So hypotenuse, which is amplitude is 10 centimeters. That means it is 0.1. Cos component 45 plus omega t. So that will be omega t plus 45. Don't put it in degrees, put it in radians. So pi by 4, of course. So 0.1 cos is omega given now, but I can find it out. How? Think about it. Omega of the SHM is also omega of the uniform circular motion. And in uniform circular motion, omega is velocity by radius. Velocity is 2, radius is 0.1. So that means it will be 20. Hence, I am just going to put this as 20t plus pi by 4 and done. Do I have it somewhere? Yes. Oh my god. Guys, this is a wrong answer. This has to be 0.1 and this is not going to be 10 unless and until. Okay, I have to change the answer, guys. This has to be 0.1 cos 20t plus pi by 4. This is the answer, okay? Ignore the answer given on the next slide. It is a mistake, okay? Fair enough. So that's the answer. Because I was so much high in Josh, and then when you see some wrong answer, I'll be like, oh my gosh. Any tips on how to approach the problems, Anthony? Simple. Visualize. Think in multiple ways. Don't believe what I say. You think what it could be. Also try problems on your own. Read theory beforehand and see how the solved examples are worked out. And the most important thing, look at the derivations. Very, very important to get a proper understanding. And yes, I have a lot of courses for you, 11th standard kids, the HC Verma course, numerical problem solving course, derivations of all the chapters, Erodo problem solving, all these things are there for you. So if you are already in Vedantu Pro's subscription, definitely you should take the full advantage of it because it's free of cost for all the VPro students. Okay, I'm very good, JEE Enthuse. So guys, you know what's the specialty of JEE Enthuse? He has changed his display picture, and guess what? You too can change and get your Warrior Ninja logo for your display picture on YouTube, and the link is there in the description box below. Download it, change your display picture on YouTube, show your love, show your support for the channel, guys. Okay, Nilakanda, it's not yet decided, bacha. The displacement of a body is given the first time from 0 to max velocity. Interesting. Let's try to think about it. First of all, over here, this pi by 3 is nothing but phi. This a is nothing but the radius. Okay, this is the radius. This 2 pi is omega. This is 2 pi radian per second. Okay, let's draw the phasor diagram. I think it will be easier. So I've just drawn the phasor diagram. Okay, these are your x and the y axis, very important. When time is 0 to the velocity is maximum. Okay, when time is 0, what angle does it make? Pi by 3. That means the phasor should be somewhere over here. Okay, this is where the phasor is at t is equal to 0, because as per the given question, the initial angle is pi by 3. Pi by 3 means 60 degrees. Cool. Now, where will the shadow fall? The shadow will fall over here. And because it goes like that, this point will go like this. This point will go like this because this point over here is going to rotate with some angular speed. So visualize. As this point rotates, this point goes here. When it reaches here, what will happen? The speed will reduce and become 0. But the question says, when is the velocity maximum for the first time? Here, this is the mean position. I hope you remember. This is your mean position. When it starts from here, speed reduces, becomes 0. Again, it turns back, increases speed. And when it turns back, this point has already reached here and this starts going here. And this phasor has now gone into the 4th quadrant and the shadow will also start going here. And when the phasor reaches here, that's when the particle would have reached here. So what it means is, when the phasor reaches over here, it has covered this much angle, your particle which was here, it would have reached here and it is going this side. See if it makes sense to all of you. Does that make sense? Okay, makes sense everyone. So basically the particle was here, it reaches here, comes over here, that's when the velocity is maximum. So you just have to figure out how much is this angle. Guys, come on, you should be able to tell me this. This is 180, this is 60, how much is the remaining? How much is this angle? Come on, tell me quickly. 180 minus 60, which is 120 degrees. 120 degrees. So all you need to think, from here to here, the time taken, this t will be the time taken by the uniform circular motion to cover 120 degrees, correct? From here to here, the phasor takes how much time? It's simple. For one revolution, it takes time period t, 120 degrees. It will obviously take t by 3, right? Because one revolution is 360 degrees. For 360 it takes t, for 120 it takes t by 3. And do I know the time period? Yes, I can find it out. So this is T by 3. Time period is 2 pi by omega. And this is 3 over here. Omega is 2 pi. So it will be 2 pi divided by 2 pi into 3. So this will be 1 by 3, which is 0.33 seconds. And do I have it somewhere? Yes. That's the answer. Got it, my warriors? Can we move ahead? Hello, dope boy. Welcome. Very good, Simran. Very good, Anthony. Very good. Bacha log. Excellent, Avipsa. JEE first attempt due date clashes with the board practicals. Oh my God. That's crazy. I just hope you get a date which does not clash, because there are many dates. I just hope you get lucky. But then bank your hopes on the second attempt, bacha. Okay, let's move on to some spring mass system problems. I hope you guys are ready. Hi, hilarious. Very good. Let's move on. So, the typical problems which involve spring mass systems are going to look something like this. You have a block which is connected to a spring, and right now let's say it is at its natural length. Now you pull the spring, leave it, it's going to go back and forth, and let's say the spring is elongated and the block is over here, and then the current extension is X, the force which is acting on it is F. This is basically your restoring force, and the velocity of that particle is, let's say, V. It can also have some acceleration and all of that. Okay, so you can see from this particular diagram that the restoring force is K into X, but with negative sign, because if you treat it like vectors, if X is right side, force is negative. If X is compressive, force is going to push it away. So it's always opposite. That's why that minus sign, correct? And when you rearrange this, you get some fancy equations like this. Like for example, bring that over here. Since F is also mass into acceleration, so you can always write ma is equal to minus kx. Bring it over here. So ma plus kx is equal to 0. Therefore, m, acceleration is the second derivative. So d square x by dt square plus kx is equal to 0. So what is this thing called? What is this thing called? This is called how to scare kids equation. How to scare underage kids equation. Okay, this is how to make them happy. Okay, this is how to make kids happy. How to make kids smile. Okay, this is the same thing, it's just rewritten in a different form. Okay, actually the formal name of this is called differential equation, guys. This is called as a differential equation. That's it. Okay, because derivatives is there, as simple as that. Okay, cool. Fantasticity, I have covered damped oscillations in Flash series. You can definitely watch it. It's not so important, but yes, if you want to watch it, definitely watch my Flash series. Just search Shreyas sir damped oscillation, you will get it. Okay, I've done a detailed lecture on that, so it's better to do it from there. Okay, I'm going to do the most important things right now. All right. Now, having said this, remember one more thing. Imagine there is one more force apart from the spring force. Let's say I call it F naught, but this force is a constant force. If a constant force acts on a spring mass system, guess what happens? If a constant force acts on a spring mass system, then the time period does not change for that spring mass system. By the way, I forgot to tell you the time period formula over here. The time period of SHM is 2 pi under root m by k. Very, very important. This is your time period, of course. And like you can see over here, it is independent of a constant force. Why this is important is because sometimes you have a spring mass system which is vertical. It is going back and forth, up and down like this. mg force is acting continuously on the spring mass system. mg is that constant force. It has no role to play. It has no role to play. Okay, Anthony, I think you should just check your internet connection and just go to advanced setting and choose a higher resolution. It will work. Okay. Now, having said that, also one important thing, this constant force does change something. It does not change the time period, but it does change something, and that is basically its mean position. A normal spring mass system will oscillate. A normal spring mass system will oscillate about its natural length. But the moment a constant force comes, the mean position shifts. What is the meaning of mean position? At mean position, what happens? At mean position, velocity is maximum, acceleration is 0. If acceleration is 0, the net force is 0, correct? And what are the two forces? Spring and the external force. So the spring force will be equal to the external force. That means kx will be F naught. That means x will be F naught by k. What is this x? This is basically the new mean position. So the mean position shifts by this amount, F naught by k. So moment a constant force acts, it will no longer oscillate about its natural length. Natural length will not be the mean position. It will oscillate about some other point. Understood? Okay, I'll come to that. 2 pi under root L by G bacha. I'll come to that. Okay, very, very crucial equations. Also, very important over here is the springs in combination. So especially, let's say for example, you have a spring and another mass over here. This is K1, this is K2. They are basically in series. In series, what is same in both of them and what is not same? This spring extends, total extension x. Total extension, the total extension x will be extension 1 plus extension 2. Also, this spring and the force in that is same because it's the same wire which is continuing. It's just the same wire, the coil ends, wire continues, another coil. So the force in spring 1 is force in spring 2, which is also the force on the mass. Same force continues. And the equivalent spring constant in series has to be found using the parallel formula for resistors. Exactly opposite that of resistors. So 1 by Ks is 1 by K1 plus 1 by K2. It's exactly opposite of resistors. Similarly, when you have your springs in parallel, let's say like this is M, this is K1, this is K2. So when they are basically in parallel, what is same is when you extend this mass, both the springs get extended by the same amount. So x1 equals to x2 is equal to x. But force on 1 plus force on 2 is the net force on the mass. These both springs will exert a force F1 plus F2 on the mass, and this time the equivalent spring constant is K1 plus K2. K1 plus K2. Keep this in mind. Okay, Anthony, it is the same force because look at this, it's the same coil, na bacha. Okay, just observe this. This is a coil and the same coil continues. So the tension here, the tension here, the tension at any point, even here, and then here, it's the same string which is continuing, and then it is finally connected to this mass. So the tension throughout the coil is the same. So hence, in series, the force is the same. Make sense? Hello, all about COD? Okay, very, very crucial. Okay, let's start solving some questions. Wow, what a question. Find the time period of oscillation of the mass connected to the pulley mass system as shown. Okay, let's do this. Okay, and then I have some more questions like this over here. Let's start with this amazing question because this will blow your mind. Okay, I'll show you the previous slide. And by the way, even if you want to go back, even in a live session, guys, we can move the slider a little bit behind and you can still watch whatever you have missed just in case. Okay, moving on to the questions now. Let's try to find the time period of oscillation for the system shown. There is a spring, there is a mass, there is a light pulley. Now, whenever you find some spring mass system, the whole concept is somehow showing force is proportional to the displacement to find the time period. To find the time period, what you should do is show that it is a simple harmonic motion, and to show it is a simple harmonic motion, the force, not any force, the restoring force is proportional to x. Just somehow show that, because whatever constant you get over here, this constant will be useful to find 2 pi. Okay, I'll just put that constant as, let's say, k, I don't know, k, if this constant is k, then 2 pi under root m by that particular constant. That's how you find the time period. So the whole challenge is somehow showing the force is proportional to x. Now what is x? That is also very important because many students make a mistake here. This x is the displacement of the mass from its mean position. Now this is a mass. There are two forces that I can think of, tension and mg. Do you think tension will change, do you think mg will change the time period, yes or no? Yes, Deepak, I'm wearing shorts and I'm so happy that at least I'm wearing that, bacha. Okay, chalo. At least you should be glad. Okay, so guys, think about it. What will happen? What is the, will mg have an effect on the time period? No, right? Very good. So forget mg. Why take tension? Oh, actually you should take tension. Only tension is going to matter because tension is going to give you the time period. Nothing else. No, it is not 2 pi under root m by k. Sorry, it is not. That's the funny part. Okay, so let's assume this mass goes over here. It moves by x. That means on that there will be a force which is restoring. That restoring force is tension. Do you agree? The restoring force is in fact the tension. Okay. Oh, don't get confused between t time period and tension t. Don't be like, sir, tension is time. No, don't get confused. Okay. Now, if this mass goes down by x, think how much will the pulley go down by? The logic is clear. See, the pulley definitely has to come down because, if you are pulling this, obviously this pulley has to move down. Only then this mass can come down. Okay, so let's say the pulley comes over here. Now imagine the pulley center comes down by 3 centimeters. Imagine this is 3 centimeters. How many strings do you get free? This side and this side, 2 sides. Here 3 centimeters, here 3 centimeters. Those 3 centimeters will go like this and fall over here. So this mass will go down by 6 centimeters. So if pulley comes down by 3 together will give you 6. The mass comes down by 6 centimeters. So if the pulley comes down by y, the mass comes down by 2y. If pulley comes down by y, the mass comes down by 2y. So the mass comes down by x, the pulley comes down by how much? The pulley comes down by how much? No, it's not 1.5, it was 3 each. Be careful, yeah. So the pulley comes down by x by 2. That is the catch. Many people write it as 2x or 4x, God knows what. Got it? Very simple. Visualize. X by 2, x by 2. Both these x by 2s will go and it will make the string tight. The mass will come down by x. That's how it works. Good. If the point has shifted by x by 2, then the spring force, how much will it be? K into the extension. Extension is not x. That's the common mistake which students make. They take the extension is x and start solving the problem, but you get a wrong answer. Extension is not x. Extension is x by 2. So it will be kx by 2. Got it, my warriors? Perfecto? Okay. Now you'll be like, sir, okay, fine. But what is tension? Because I have to show tension is proportional to x. Draw the free body diagram of the pulley. Draw the free body diagram of the pulley, guys. If you draw the free body diagram of the pulley, you will see the spring force is up and it is kx by 2 and there is a thread which is wrapped over it. So there is a tension here and the same tension here. Now I know what it is. These two tensions, T plus T, is equal to kx by 2. So 2T is equal to kx by 2. So T is equal to kx by 4. Look over here. If restoring force is proportional to something into x, something, what is that something? That something is here. That is your constant. Hence, time period is 2 pi under root m by k. K is k by 4. So this will be 2 pi under root 4m by k. If you want, take that 4 outside, 2 2s are 4. So it will become 4 pi under root m by k. That is the answer. Got it, my warriors? Very good, Simran. Excellent. Yes. So the idea was mg is not relevant because it's constant force. So tension nahi lene ka, you should not take tension, but you should take this tension because that tension is variable. Why is that variable? Because it is indirectly connected to the spring force. And you saw the relationship between tension and the spring force, and somehow I showed it proportional to x. That's what you should always do. Excellent. Moving on to the next question. Got it? Very good, Arvindar Kumar. Here's the question. Coming on your screen, a periodic time of a mass suspended by a spring, force constant K is T. If the spring is cut into 3 equal pieces, the force constant of each part and the periodic time of, if the same mass is connected, suspended from one piece will be. Interesting. No problem, happens, Anthony. You are here to learn. Don't worry. Okay. So you have a spring. You cut it. Okay, I'm cutting it into 3 parts. So 3 parts, okay. So I get 3 springs. Good. Reminds me of those days when you were in school and you had problems like your mom has made 2 chapatis. 2 chapatis have to be divided with your cousins. There are 3 cousins and you, and there are 4 people. How are you going to divide those 2 chapatis? 2 divided by 4. Oh my God, what a question. First standard. And look at these questions these days, hai na? Do you like this or that? Dividing chapatis, dividing cakes. So nice. Such a nice time it was back in first standard. And look at where we are. Where am I staying in Bangalore? Oh my God. I should not reveal my address or else I will have paparazzi outside my house. Okay, so this is K1, this is K1, this is K1. Equal, right? K1, K1, K1. Series makes it this. Because I've split it, so if I combine it, I should get the original thing. So hence, 1 by K will be 1 by K1 plus 1 by K1 plus 1 by K1, which means it is 3 by K1. That means, rearrange. So this will become K1 is equal to 3 times of K. So equivalent spring constant is 3K. Very good. 3K, 3K, 3K. Okay. So obviously option A is out of question. What about time period? Okay, we can figure that out. When you had one mass connected here, the time period was 2 pi under root m by k. But when you took any one of this spring and connected the same mass, the time period will be 2 pi under root m by k1. But k1 is nothing but 3k, so that root 3 can be taken outside, 1 by root 3, and you have 2 pi under root m by k. That means it is t by root 3. So t by root 3 somewhere? Yes, option D, I guess. Very good. D, 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 D. Done, done, done. D is correct. Very good, Arvinder, Deepak. Just know, Anthony, excellent. Here comes the next question on your screen now. 2 springs, 1 mass. Both are made 4 times. Both the spring constants are made 4 times. The question is, how many times will the frequency become? Okay, I'll give you 1 minute. Let's see how many of my warriors are very good at this question. 1 minute. 1 minute, guys. Come on. Let's see how many of you can do this. Somebody saying D. Hello, Nivesh. Welcome all the new warriors. If you are joining in a little bit late, you can watch the replay of the session later on too. And yes, do not forget that this is the English medium channel for JEE, and do not forget to hit the subscribe button so that you get more updates, more lectures, and for your entire 11th standard revision too. Let's see, guys. Come on, figure this out. 30 more seconds. I'm hoping that you guys are going to post the answers. Cool. Very fast. You got the answer. Come on. Let me know. Is it 2F? Is it F by 2? Is it F by 4? Or is it 4F? Hello, Subrata, Sardar. Welcome, Pacha. 10 seconds to go. Come on. Come on. Come on. You should be able to do this. I'm not going to tell you whether it's right or wrong. 5, 4, 3, 2, 1, and there you go. Okay, let's figure this out. Yes, unique gamer, wake up. Oscillations, waves, it's all there, bacha. It's all important topics. Please don't skip it. Guys, these 2 springs, are they in series or are they in parallel? First, you need to analyze that. I feel that each of these springs are in parallel, reason is, imagine this, if you move this block somewhere over here like this, you move it by some small amount, then this spring will apply a force F1, it will extend, it will pull it, this spring will get compressed, so it will apply a force F2. Both the forces are in the same direction. This situation is same as this situation where you had two springs on the same side, and when you pull this block this way, both the forces are in the same direction. These two are equivalent. So whether the springs are on two sides or whether they are on the same side is one and the same thing. Hence, the springs are in parallel. The springs are in parallel. And what's the effective spring constant? We all know that if springs are in parallel, Kp is K1 plus K2. Now, as per the question, the spring constants are made 4 times. So, if each one of them is made 4 times, obviously their effective constant will also be made 4 times. And what is the formula for time period of a pendulum? Time period of SHM. Time period is 2 pi under root m by k. So think about it, if k, which is here, becomes 4 times root of 4. Root of 4 is 2. So time period will become 1 by root 4, which is 1 by 2 times. So time period becomes half. If time period becomes half, think about the frequency. Frequency is 1 by time period, and if time period has become half times, frequency will become 2 times. Hence, option A is correct. Correcto, Divyanshi. Very good, option A. Savis Jalan Riala, tomorrow I'll be doing waves, the complete waves, sound waves, waves on a string for 11th standard revision backlog series. Okay, so remember that. Option A is correct. Okay, let's go to energy of SHM. Yes, it is inversely proportional. Okay, and yes, make sure that you go and join the Telegram channel because we keep updating the schedule, and also on the YouTube community we keep uploading what we are going to conduct the next day. Okay, now simple things for energy. The kinetic energy of a SHM plus the potential energy is going to give you the total mechanical energy. This mechanical energy of a SHM, remember, is constant. Okay, potential gets converted into kinetic, kinetic gets converted into potential. The kinetic energy formula is obviously simple, it's half mv square. The potential energy formula is half kx square, and the total energy formula is half ka square. As simple as that. And graphically speaking, you should remember this graph, which is very simple and very common also. If this is x and if this is your energy, you will notice that your total energy is constant no matter where you go. The total energy is always constant, but your potential and kinetic keep changing. Potential is maximum when it is extended or compressed. So it will look something like this. This is your potential energy, but your kinetic energy is exactly opposite. Your kinetic energy will look something like this. Okay, so their sum is constant. One increases, the other decreases, and it will always try to balance itself. Very crucial things related to energy. Obviously, you can use the formulas for velocity and position, like you can use a omega cos omega t over here if you want it as a function of time, and for x you can put a sine omega t in case you want to replace the value of x over here or velocity over here. Okay, keep this in mind. All right, let's start solving some questions. I don't think so. Yeah, we have to find this. Yeah. A particle executes SHM with a frequency f. The frequency with which its kinetic energy oscillates is how much? Yes, A is the amplitude. Oh, A is the amplitude, guys. I'm so sorry if you didn't realize that. Yeah, A is the amplitude. Same A, amplitude. Okay, cool. Let's do this question. A particle executes. Yep. Okay, I'm so happy, Anthony. Particle executes SHM with frequency f, the frequency with which its kinetic energy. Guys, think about it. in a oscillating system, a system which oscillates like this, correct? How will the position graph look like? The position versus time graph looks like this. This is your one time period. This is your one time period, correct? How will your kinetic energy or other things vary? If you talk about kinetic energy or potential energy, let's say we talk about kinetic energy, here your speed is maximum. Speed is maximum, correct? It becomes 0. So from here to here, it goes like this, maximum to 0. Again it increases when it comes back. That's it. Again it decreases. That's it. Again it increases when it comes back over here. Like this. This completes your one oscillation. One oscillation. In one oscillation, look over here. Its maximum kinetic energy decreases, increases, decreases, increases. One oscillation. So you'll be wondering, sir, what is the frequency of the kinetic energy? Guys, although it is one oscillation, the time period for kinetic energy is not this entire thing. In fact, only this much is one time period. Because after this part, it's a repetition. Do you see this is continuously getting repeated? This is the part which is getting repeated. So the time period has been halved. So if time period is made half, the frequency has to be doubled. So hence 2F, option C should be correct. Option C. Did you understand? It's a repetition which has changed. Here, if you notice, this is one cycle. The motion repeats itself after this. The time period was this much. Here, the time period is only this much. Okay, fair enough. Moving on to the next question. This is one of the most crazy question, and I have seen some weird solutions everywhere, and I'm pretty sure after this solution you'll be like, okay, that's why we should not look at solutions on the internet, because it is going to just screw our mind. All right. Now, the instantaneous displacement of the mass executing SHM on a with a force constant K, this time average of the kinetic energy of a time over time period T. So basically what it says is, in one oscillation, what is the average kinetic energy? The problem is velocity is not constant. So to find average, you should know the definition of average. The definition of an average function is integral k dt from 0 to t upon t, and kinetic energy is nothing but half m v square and dt upon t, and therefore that half m comes outside, t is there as it is. Velocity square, v is nothing but a omega cos omega t whole square dt, and then 0 to t. Now if you do this, it's going to be crazy. Yeah, you have to keep solving this integral and then you will get the answer. This is the textbook way of solving. This is the longer way of solving. I'll teach you an easy way. How many of you want to do like this? Up to you. You can try to solve it via this method. You will get the same answer. This is the integral way via definition. The definition of averages. But I'm not going to do all this nonsense. Okay. What am I going to do? Let's see. My God. Okay, just 1 second guys, let me erase this. Okay, what I'm going to do is, I'm just going to tell you one simple fact. The simple fact is, the average kinetic energy plus the average potential energy will be equal to the total energy. The average value of the kinetic and the average value of the potential together is going to give you the total energy. Could you guess this? Everybody getting it? Makes sense? Now, kinetic energy gets converted into potential. Potential gets converted into kinetic at some point or the other. Maybe not simultaneously, but with a phase difference. So, don't you agree that the average value of the potential, energy is definitely equal to the average value of the kinetic energy? Maybe not at the same time, but average over one cycle, because potential goes into kinetic, kinetic goes into potential. When this is maximum, this is minimum. When this is minimum, that is maximum. So hence, can I not say 2 times? So from these two, Can I not say the 2 times of average energy is the total energy? And what is the formula for total energy? It is half K A square. So this will be 2K average. So what is the kinetic energy average, guys? It is 1 by 4 K A square. Where is integration? Where is complicated maths? And what is this? Option B, done, done. It is correct. Moving on. I'm very good, Abhishek. Got it? So this is how you can solve questions by different methods. You should always think on your own independently. Just don't go by textbook methods. And when you are in my classes and when you are taking up, all these problems, always I initiate and always appreciate your, original or your intuitive thinking. It's very important. The unique thinking is very important. Moving on to the next question, guys. Okay, very good. Moving on to this question. Body is executing SHM. Potential energy for A displacement is EA. For B displacement is EB. What is the potential energy for A plus B displacement? Okay, let's see how many of you can do this. Okay, potential energy for A displacement is EA. That means EA will be half K A square. Potential energy for B displacement is EB, so half K B square. Question is, what is the potential energy for A plus B displacement? So potential energy for A plus B displacement, let's say I call it E. So that's what is mentioned. So E will be equal to half K A plus B whole square. A plus B whole square. Where is omega by K used? I'm not sure. What do you mean by that? Omega by K. Omega by K is nothing. That one, Abhishek. That omega by K is in waves, not in SHM. That's wave speed. Don't get confused. That's some other chapter. Okay. Now, put up the answer, Anthony, if you got it. Now, to do that, I need to substitute the value of A and B from here. So how about rewriting this equation? From here, A will be equal to 2EA by K, and from here B will be equal to 2EB by K. Use these values over there and see what you get. You will get half K A plus B. So this plus this. So 2EA by K plus, this was A square, right? I'm so sorry, guys. This was A square. So this will be whole thing under the root. This is also under the root. Yep. So that means this will be also under the root plus 2 root EB by K, and this is whole square. Now let's see what do we get. Half K. Square this. So A square plus B square plus 2AB. So A square will be 2EA by K plus B square will be 2EB by K plus 2 into A into B. So that will be root of 2 2s are 4 into EA EB by K square. This whole thing. So K goes, 2 goes, correct? K is going everywhere. K square will come outside, it will become K. 2 is also going everywhere. So what is remaining is EA plus EB plus 4 will come outside, it will become 2 root EA EB. That's what I'm getting E as. But then if you look over here, I don't think any option is matching right now, but there is one small thing remaining. Only after that you will see the match. This is nothing but root EA square plus root EB square plus 2 root EA EB, right? Now does it look familiar? A square plus B square plus 2AB. Now you get it, right? What is this? This is nothing but root of EA plus root of EB whole square is nothing but E. So taking root on both sides, root E will be root EA plus root EB. That's it. Is it there somewhere? Yep, it is. Option C. Option C it is. Correcto. Very good, Simran. Very good, very good, very good, very good. Yes. Got it? Clear? Understood? This has a lot of mathematical manipulations. So this is the most crucial step in this equation. Many people get it till here and then they get confused what to do next. None of the options are matching. Is it a bonus or what? No, it matches perfectly. Okay, let's solve the next question coming up on the screen now. The total energy of the body executing SHM is E. Kinetic energy is 1/3 of the total energy and the displacement of the body having the amplitude A is. According to the question, total energy of the body is E. Kinetic energy is 1/3 of the total energy. So the kinetic energy is 1/3 of the total energy. When the displacement of the body is question mark, when will this happen? What should be the displacement? The formula for kinetic energy, well, that's half mv square. Okay, I don't get anything much over here because v is velocity, but the question is displacement x. Although I can use the formula for velocity to convert it into x, I don't like to do all those nonsense because it might stretch the problem. Guys, I'll use a simple logic. If kinetic energy is 1/3, how much will be potential? How much will be potential? Come on, put it up in the chat box. Yes, obviously you need maths for physics. That's why many NEET students find it difficult, because you guys think, or probably sometimes students are being told that it's okay, even if you don't know maths, you can still survive physics. And that's why many NEET students find it very difficult to get very good marks. So you should, maybe I won't say you should love maths, but you should be comfortable with maths. Only then you will be able to solve the physics problems. Potential energy, how much will it be? If kinetic is 1/3, potential energy will be 2/3, right? It will be 2/3 of the total. Reason, since potential plus kinetic is total. So if kinetic is 1/3, potential will be 2/3, the remaining part. Correct? Got it? Okay. Potential energy formula is half k x square. Correct? This will be 2/3 E total half k a square. That's the formula for total energy. Half k goes, x square will be 2/3 a square. So x will be root of 2/3 into a. Done. Is it there somewhere? Root 2/3. Yep, option A. You can see that. Cool. Everyone, very good, Anish Kumar. Very good, bacha log. You guys got it. Okay, let's move to the next question. And for that, we'll need to see angular SHM. Angular SHM and problems. So what is angular SHM? Basically, till now, whatever we saw involved linear SHM. This was linear. You had mean, you had extreme right, extreme left. This was along a line, so linear SHM. Angular SHM means you go in the form of an arc of a circle. This is your center. This is again your mean. There is your extreme right and extreme left. And what happens is your particle makes a certain angle theta, and it goes back and forth, along that arc. The maximum extremes, the max extremes, these are your extremes. These angles and this angle, they are called theta naught, which is angular amplitude. That's the only difference. Wherever you find x, replace it by theta. Wherever you find amplitude, replace it by angular amplitude. So in linear SHM, x was a sine omega t plus phi, right? Over here, in angular SHM, okay, this is your angular SHM, because angle is changing as a function of sine function. So instead of x, you will have theta is equal to theta naught cos omega t plus phi. That's the only difference. That's all. This is angular amplitude, and why did I put cos? Sine. You can put cos also, no difference. Okay, you can put sine or cos, doesn't really matter. And just like in linear SHM, f was minus kx, right? Here, instead of force, you will have torque is equal to minus k theta. This k is called as your torsional constant. Torsional constant. When you rotate it by theta, how much is the torque proportional to per unit angle? That's your torsional constant. It's like your spring constant, but for angle. That's the torsional constant. No, it is not tough. You will see that. It's very similar. And over here, you had time period is 2 pi under root mass by spring constant. In angular SHM, time period, okay, this is your time period of oscillation. Okay, it will be 2 pi under root. You will not have mass because it is rotating, it is angular. Instead of mass, you will have moment of inertia by this torsional constant. This is your moment of inertia. Moment of inertia. Keep this in mind. Got it? Perfect? Perfect? Got it? This is very important. So if you know these formulas, you should just know the corresponding variables. Position, angular position. Amplitude, angular amplitude. Torsional constant, spring constant. Force, torque. Mass, moment of inertia. Everything is similar. Same thing even for omega, right? Omega is root of k by m. Here, angular frequency is root of k by moment of inertia. Everything is similar. Got it. Very good, Aishwarya. Very good, Anish. Keep this in mind. Now, there are two specific cases for angular SHM which you should know. One is simple pendulum, one is physical pendulum. So I'll just put it over here. Physical pendulum, and you have simple pendulum. What's the difference? You take some big object, like say for example this one, where the mass is not at a point but it is distributed. You have a hinge. The center of mass is somewhere here. This is the distance between the center of mass and the hinge. You will see when the body is displaced and left, the gravity will pull it back, and by the time it gains momentum, it will overshoot and it will go like this and like this, oscillate. You hold anything like this pen, you pull it like that and leave it, it will oscillate like that. So this is a physical pendulum, but in a simple pendulum, all the mass is concentrated over here. This is massless, and you have this point of suspension or hinge over here. That's the only difference. Mass is concentrated, here mass is not concentrated, it is spread out. The center of mass is over here. Yes, definitely Dream IIT Bombay. Many people realize their mistakes, they start working, and 1 year also is sufficient to crack JEE Advanced plus mains. Okay, now when you're talking about physical pendulum, the time period is 2 pi under root moment of inertia about the hinge upon mgd. D is the distance from the point to the center of mass. But for a simple pendulum, time period is 2 pi under root L by G. That's how it is. So for physical pendulum, it is moment of inertia by mgd. For simple pendulum, it is 2 pi under root length of the pendulum by G. This G can be also G effective for accelerated frames of reference. For accelerated frame of reference, it will be G effective. That's all. Yep. So basically, you can convert physical pendulum into simple pendulum. Imagine simple pendulum, moment of inertia will be ml square. So instead of I, you put ml square. D will be L. So if you solve it, you will get the same equation. So this is a special case. This is a more general case. Think moment of inertia will be ml square. This will become mgl. LL goes, mm goes, L by G. That's the same formula. Is it seconds pendulum? No, seconds pendulum is completely different. For a seconds pendulum, so for a seconds pendulum, the speciality is that the time period is 2 seconds. That's the thing. 2 seconds. And when you put 2 seconds, 2 is equal to 2 pi under root L by G, 2 goes, and you will get this as root of L will be nothing but root of G by pi. Root G is roughly pi, so this will roughly be 1, and L comes out close to 1 meter. So when length is roughly 1 meter, time period is 2 seconds, 1 second here, 1 second there. That's called as a seconds pendulum. Let's start solving some questions. Munish, I have done a one shot in 0 to hero. Just search on YouTube Shreyas sir communication system. You'll get it in the first 2 results. Okay. Anthony, that is a bit too much. I mean, you can prepare for JEE from 5th standard too, but you can prepare for Olympiads. there is no need to prepare for JEE per se. Prepare for scholarship exams like NTSE, prepare for Olympiad exams, but that's okay. But preparing for JEE from 5th standard, I don't recommend it, okay? Although you will be like, sir, what are you saying? You are teaching in a JEE institute, and I have heard many institutes saying you should start preparing from the 2nd standard. Guys, we are not like that. In fact, we don't believe in those things. 2 years to 3 years is very good to prepare for JEE, okay? And many of the students, including me, have cracked, and all my friends, all my students have cracked JEE within 2 years. So enjoy life, develop habits, develop qualities. JEE is not everything. You have to learn different skills also. You should learn music, you should learn sports, you should learn arts, you should learn drama, you should learn singing, you should learn dancing, you should learn painting, you should learn to play outside, you should learn all these skills which are very important in life. Okay, JEE happens. All my students who have even got 2-digit All India rank is a very good pianist. One of them is a very good dancer. He went to Shamak Dhaval classes and all of that. So, that's what is very important. It's not just preparing from the beginning. Preparing early helps, but then you're losing out on many things in life. That's what I would say. Okay. Great. Let's see how many of you. Yes, option D is correct. The motion of torsional pendulum is angular simple harmonic. Obvious. I wouldn't comment about other institutes, but we believe that foundation is different, JEE preparation is different. Many students prepare for scholarship exam. Scholarship exams are different. Yes, you should prepare for scholarship exam. There will be NDSE, there will be what is that? Oh my god, it's slipping out of my mind, but yes, these Olympiad exams are obviously there for even the lower grades. You should prepare for these exams, bacha. Yeah, cool. Yep. Next question: the time period of oscillation of a simple pendulum, which is in a vehicle which is moving down without friction on an inclined plane of inclination theta is given by. Okay, come on. Astha, this is for 11th standard students, bacha. That to a backlog session. If you are in 10th, watch my bridge course. It's there in the nurture playlist. You can go to the nurture playlist tab. Yeah. So just go over there and that will help you. Okay. Great. Come on. Let's see. Game changer saying C option. Okay. Let's solve this. Time period of oscillation of a pendulum of length L suspended from the roof of a vehicle and it moves without friction down an inclined plane. So guys, if you have a vehicle and it is moving down like this, and if there is a pendulum over here, it is oscillating, what matters is the effective gravity. Because when I write time period is 2 pi under root L by G, this is always the effective gravity, especially in accelerated frame. Now if you notice in this frame of reference, there is a pseudo force which will act like this, and pseudo force is mass into acceleration, and acceleration is obviously G sine theta, correct? Acceleration is G sine theta. It's accelerating down. Gravity is down, mg, but I can split mg into two components. One component here, which is mg, because this will be theta, this will be mg cos theta, and this will be mg sine theta. So you can forget this now. Now quickly tell me, there is mg cos, mg sine and mg sine. What will happen? Mg sine and mg sine will cancel, right? Don't you see that? Mg sine theta and mg sine theta will cancel, right? If both these forces cancel, what is remaining? Only mg cos theta. That means the gravity in this place, in this vehicle which is accelerating down, is only because of mg cos theta. So the G effective should be only G cos theta. G effective only should be G cos theta. Hence, instead of G effective, put G cos theta, and there is only one option like that, and that is option A. Option A, guys. Yes, Simran, it is correct. Yes, Abhishek. Harisharan, yes, you will have physics classes daily, bacha. Sometimes 11, sometimes 12. Tomorrow I am going to have waves backlog and revision session. If you take a pendulum and if you arrange it in a vacuum jar, then what will happen? It will stop oscillating, it will continue to oscillate. It oscillates with slightly more time period. It oscillates with slightly less time period. What do you think? Yes, Munish, it's more than enough. It's an easy chapter. Keep NCERT in front of you. watch my one shot, more than enough. This is for backlog covering a revision, both Siru, because some students wanted live classes, because live classes, the whole intention is completely different. Okay, you can interact, number one. Number two, also many students need that one shot revision session for, you know, different chapters. So in the one shot you get a good idea of what and all breadth of the chapter is there, and once you understand what and all topics, subtopics, and what is the type of questions are there, then wherever you find it difficult, you can start looking at the detailed classes. So both type of lectures are important, Siru. Okay, let's solve this question. Infinity, an oscillating pendulum, if it is arranged in vacuum, what role does air have? Does air have any role? No, right? 2 pi under root L by G. What will vacuum do? Nothing. What will G do? What will air do to G? Nothing. So there is no difference. It will continue to oscillate. It is just a trick question. People unnecessarily, when asked something, they will be like, oh my god, what will happen? Nothing will happen. It is still going to oscillate. What will happen? Yeah. What is like, I'll definitely let you know someday, Blessy. We'll make a session on 4D2. Okay, it's not infinity. Okay, Harishan, come on, look at the next question. Thin disc or radius R, mass M, suspended as a pendulum in vertical plane from point O. At a distance, it undergoes small angular SHM. For what angular for what value of x the amplitude of angular acceleration of the disc is minimum? Okay. Now, here comes the challenge where you will have to solve this based on derivatives, guys. Yes, based on derivatives. So, imagine this. Time period has to be, the amplitude of which the angular acceleration of the disc is minimum. The angular amplitude of angular acceleration of the disc. What amplitude is? I think there is something wrong over here. The amplitude, I don't think it should be amplitude, guys. I think it should be time period, most likely. The amplitude of the angular acceleration of the disc, I think something is wrong over here. Amplitude of, oh, okay. Fine. It's okay. Amplitude of the angular acceleration means, okay. See, angular acceleration, which is alpha, okay. Just like you have acceleration, you have angular acceleration, that will be nothing but a omega square. That means it will be theta naught into omega square. This becomes the angular acceleration's amplitude. This is the max value. The max value of the angular acceleration, that would be a omega square. Now you want this to be minimum. You want this to be minimum. If you want this to be minimum, you want this to be minimum. Now if you want this to be minimum, that means you want omega to be minimum. You want omega to be minimum. Now if you want omega to be minimum, that means you want time period which is 2 pi by omega. This omega, if you make it minimum, then time period is maximum. Now here is the thing for solving the question. If you want to maximize the time, think about the formula for time period. Time period is 2 pi under root I by mgd. Somehow can I rewrite this equation in terms of x? Observe. I think I can. There is this body, this disc, okay? This disc is there, okay? This disc is there, and it is in a vertical plane. It can oscillate, and it is hinged at point O, which is at a distance x above the center. So this is the hinge point, this is the center, this is x. So how will this moment of inertia look like? This moment of inertia will be found out using parallel axis theorem, which will be moment of inertia about center of mass, which is mr square by 2 plus mx square, correct? That will be the moment of inertia. And mgd, d is the distance from center to the hinge point, so it will be into mgx. So now this equation will look something like this: 2 pi under root. Okay, so I have over here, I can write this as basically mr square by 2 and mgx is there, so mgx plus here I have mx square by mgx. Now you can simplify this and write it as goes cancel, so r square by 2gx plus here you have x divided by g. Now the reason for writing it this way is once you get time as a function of x, the question is you have to maximize the time. If you want to maximize the time, you have to use the concept of maxima. You have to use the concept of maxima, and the concept of maxima is whenever there is a maxima, remember the derivative is 0. So differentiate this, and once you differentiate, you will get the value of x. Can you try this out? Will you be able to differentiate this? Yes, you have to use the concept of maxima and minima. Yep, the answer will be r by root 2 when you solve it. Okay, understood the logic? Yep, concept of maxima minima I have taught you, and watch my nurture series classes. I have told you about the concept of derivatives and maxima minima. Let's solve the next question coming up on your screen now. Okay, 3 physical pendulums, this and this, uniform spheres of the same mass that are rigidly connected by rods and length L, negligible mass. Each pendulum is vertical and can pivot about the suspension point P. This P is the suspension point. I'll mark it over here. This is suspension, this is suspension, this is suspension point. Compare the time periods. Very simple. Compare the time periods. Very simple. Let's see how to do this. For the first situation, this is the first situation. So for the first situation, it is like a simple pendulum. It's basically a simple pendulum. And for a simple pendulum, what will you do? The time period will be 2 pi under root L by G. As simple as that? Okay. This one, the one in middle, be careful for the second situation. The center of mass is exactly over here. Why will it even oscillate, bacha log? Think. Why will it even oscillate? It will not oscillate because center of mass is here. No matter how you put it, center of mass will always be there. It will never have any time period. So for the second situation, center of mass is at the hinge. Hence, the oscillation time period, even if you do it, time period will tend towards infinity. Even if you use the formula, which is 2 pi under root I by mgd, this d tends to 0, so time period tends to infinity. Great. For the third situation, what is it? Yep. In this situation, it's like a physical pendulum, 2 point masses. So let's find the time period. Time period is 2 pi under root. Moment of inertia, ml square plus this mass is at a distance of 2L, so m into 2L whole square upon mass, which is 2m, total mass. Center of mass will be here. For the third situation, center of mass will be here. This distance will be 3L by 2, correct? At the exact center. So 2mg into 3L by 2. Okay, what will this be? ml square plus 4ml square, 5ml square. So 2 pi under root 5ml square divided by 2 gets cancelled, so you will get 3mgl. So this will become 2 pi under root, goes by ll goes, so 5l by 3g. Now you just have to compare l by g, 5l by 3g and infinity. Obviously this is the smallest, then third, then second. First, then first, third and then second. Okay, it should be option C, not option A, guys. This is wrong. This is correct. Okay, first, then third, and then second. Is that making sense? No, it is not D. It is option C. Okay, Akash. Welcome, Akash. Hello. Is root 0 infinite? No, Harisaran. Root 0 is 0. 1 by root 0 is infinity, tending towards. Okay, Joshua, you will get around 4 marks to 8 marks for SHM related chapters. Got it, bacha log, everyone. How is the hinge at the center of mass? Jisnu, for the second situation, this mass is here. This mass is here. Where will the center of mass be? Exactly at the center. And this P is the point where it is pivoted. So, where is the center of mass? At the hinge. Hence, if the distance from the center of mass and the hinge will be 0, 1 by root 0 will be infinity. Hence time period is infinity. Akash, did anybody tell that you cannot do it? Yes, obviously, bacha, you can do it. Stay consistent, stay focused, watch all the classes, watch all the sessions which are there on the channel. Trust me, if you follow all the strategies, you can definitely get into IIT Delhi one day. And you will come back here and say that, sir, right now I'm in IIT Delhi and I'm doing this courses. And I will be waiting for that. The last part of simple harmonic motion, are you guys geared up? I hope you have not lost energy, because if you lose energy, I will lose energy. I have not lost energy. Yes, Akash, we do have courses for IIT. You can check out the link which is there in the description box below. For the pro subscription, you have the pro subscriptions for all of you. Hi Rishi, I am very good. Okay, so superposition of SHM. Whenever two SHMs are superimposed means they are basically added. Then together they will produce a resultant SHM of same frequency, but the amplitudes are different. For example, imagine you have one SHM whose amplitude is A1, angular frequency is omega. Another SHM whose amplitude is A2, angular frequency omega. Now, when you add both of them, what you get is a resultant SHM. You will get a resultant SHM, I'll call it A, of the same angular frequency. This is your resultant. Very, very important. And how do you find the amplitude is very critical. These two SHMs, which are being superimposed, they are added over each other, they too might have something called as the phase difference between them. Phase difference. Whenever you have two or more SHMs and they are added onto each other and they are not together, then you should add them like treating them like vectors. And how do you solve that? Simple. Draw the amplitude of the first SHM as a vector. Let's say I draw it as A1. That's a vector A1. Length corresponds to the amplitude. Take the second amplitude, draw it like a vector, but at an angle of del phi, because there is a phase difference. So draw the second vector A2 and that angle is del phi. Now the resultant of both of them, that will be somewhere here. That is the resultant amplitude of the superimposed SHMs. That's it. Hi Asami, welcome. Hello Feroz. Hello Ganesh, welcome Bacha. That's it. So remember one thing, this A vector is nothing but A1 bar plus A2 bar, but magnitude wise it is a root of A1 square plus A2 square plus 2A1 A2 cos del phi. Okay, cos del phi. Keep this in mind. That's the magnitude. Got it? Yes, you can ask me, Feroz, no problems. So whenever two or more SHMs of same frequency are added, add their amplitudes like vectors. The resultant vector is the amplitude of the resultant SHM. That's all. Keep this in mind. Okay, so resultant is also SHM. Let's solve some questions based on this. Selva, if you want that, there's a very simple thing which you can do. Yeah, same like vector addition. Guys, many people keep asking me the same thing, so let me just put it right over here. See, bacha, on this channel, right? If you go to playlist, down. Do you see this? JEE 12th. Here you have JEE 11th, Maths, Physics, Chemistry. That's it. Click on this view full playlist. When you say view full playlist, do you see? Right from units and dimensions to the last lecture. Everything is there. That's what you wanted, right? Correct? So everything is there. And I'm pretty sure you will watch it. Okay, cool. Let's go to the question coming up on your screen. Akash, I'll tell you one simple reason. Number one, every institute will tell that we have the best teachers. Yes, every institute will have the best teachers, obviously. One thing what makes Vedantu different is that we really care for our students, like to extreme extents. Whatever, I know what my students are thinking, I know what is needed next. That is number one. That sense of ownership is there, responsibility is there. It's not like, okay, it's a class. Although it is the online class, trust me, the interaction is far superior than the offline institutes. Number two, we have our own unique platform which is called as Wave, where you have quizzes, polls, leaderboards, appreciations, all of that, which keeps you engaged. When you're watching a regular lecture, even on YouTube, it is not so engaging. Trust me, the Wave platform is more engaging because you have lots and lots of features. Plus doubt solving which you get, the materials that you get, the data points that you get for every test and assignment is too much. I mean, that is something which will make you improve as an individual, as a student, and that's what every student needs. It's not just the total score which matters, it's the points, the data points. How many marks you lost in this concept, how much are you getting in easy questions, that's what is important. Okay, right. So let's see how many of you can get this. Okay guys, first of all, did you realize A0 is a constant? Did you realize that? If A0 is a constant, it should not even matter. Just forget that. But this one, this is the only thing which matters to me. I'll tell you what I'll do. This constant, it's just going to shift up and down. It will not change the amplitude. So forget that. This is as good as saying A sine omega t plus B cos. Cos I can write it as sine omega t plus 90 degrees, right? Sine theta plus 90 is cos. This is the same thing, amplitude over here. This constant will not change the amplitude. It's a constant, remember. It's just going to shift. It's not going to do anything. Now, guys, these are two SHMs. Did you realize that? SHM1, SHM2. What is their phase difference? 0, 90. Phase difference is 90 degrees. Amplitudes are known. So the resultant, this is one vector, this is another vector making 90 degrees. So what is the resultant going to look like? The resultant, because both are at 90 degrees, it will be a square plus b square. And is it there somewhere? Option C, correcto, excelente, amazingo. So glad, Akash, 09. Very good, Jisnu, Avisa, very good. Anthony, Jisnu. Salwan, what basis does NIF ranking done and how is VIT? Even I am very surprised, Selva. Trust me on that. Whenever I see that VIT ranking is more than BITS ranking, I'll be like, okay, just let's not see that and get disappointed, because so many of my students are there from VIT also and BITS also, but I see, I'm not comparing students. I don't want to do that, because eventually it's up to the individual. You can grow up to any level, whatever you want. It doesn't matter which college you are from. Okay, you can be from IIT and you can do very horrible, but the average is what matters. The average people are much better in BITS. That's what I have seen. Be it placements, be it research, be it personality, be it so many things. So even I get surprised. I don't know how it happens, Two particles execute SHM of same amplitude and frequency along the same straight line. They pass one and another when going in the opposite direction, and each time their displacement is half their amplitude. The phase difference between them is the best IIT, many IITs. There is nothing like the best IIT. Every time one IIT comes on the top. Last year it was Madras, before that Bombay, before that Delhi, before that Kanpur. So it keeps changing. It doesn't matter. It's not like, sir, I did not get IIT Madras, now I'm in IIT Bombay, sir, what to do? Guys, it doesn't matter, okay? Once you're in the top 7 IITs, even if you're from IIT Guwahati, it's the same thing, okay? It's just there in your head. That's what many coaching institutes do. You have to be in IIT Bombay only, computer science, top all India rank 50. Oh, guys, where are you guys? What are you guys doing? Thank you, Parvati. Love you too, bacha log. What is the difference between YouTube channel and actual platform? Oh, a lot of difference, Akash. There is a class teacher, second teacher is there. Doubt solving is going on. Personal attention. Chat is regulated. Quizzes are there. Hotspots are there. Polls are there. Yes, no's are there. PDF gets downloaded, tuck, gone. Replays are there. Okay, it's more customized and more systematic, obviously. You got 120, let's see, bacha. See, two SHMs are there, right? Two SHMs. SHM1, SHM2. They cross each other when going in opposite direction. Each time the displacement is half their amplitude. If this is the mean position, half the amplitude is over here. This is a by 2. One of the particle is going this side. The other particle is going this side. Let's solve it by phasors. Let's solve it by phasors. Okay. And amplitude by 2 will be somewhere over here. One is going there, one is going here. That means the respective phasors, one of the phasors will be here, going like this, whose projection is here. That's why the particle is going this way. The other phasor will be like this, whose projection will be here. And because it is going like this particle will be going like that. They're crossing. Now it's done. Simple. How? Observe. Okay. Observe. This base is a by 2, right? This thing, this is a by 2. This thing is a. This thing is also a. Fine. Now, if that's the case, how much is this angle? This is hypotenuse, this is adjacent side, this is half. That means this should be 60 because cos 60 is half. If that is 60, obviously even this is 60. So obviously if this is 60, this is 60, what is the total angle between them? Obviously it is 60 plus 60, which is 120. That's the phase difference. Where is it? Option D. Done, done, done. Akash, the pro cost, I think it comes close to, depending on, there are 3 packages. One is light, which does not give you doubt solving, but everything else. The second one, the classic one, gives you doubt solving also. Okay, that's close to around 50 to 60,000 or 70,000. For 2 years. Okay, and then you have the plus version where you have personal mentorship. You get a dedicated teacher for solving all your doubts. I'll show it to you if you want. It's there. You just go down in the link. Sugbag, okay, Bachap, can you please leave a comment after my photo so that I can find your Instagram and reply to you directly? Hi, Balamurgan. Very good. Okay. Yes. Great. Moving on to the next one. Okay. Cool. Cool. Right. So last question for today, I guess. 3 SHMs are in the same direction, same amplitude, same period, added over each other, but each one differs with the next with a phase difference of 45 degrees. The question is this: which of them is correct? More than one option will be correct. Okay, more than one option is correct. Let's see how many of you can get this. Resultant amplitude, phase difference, energy, etc. First of all, let's visualize. There are 3 SHMs, each one differs with the next one with 45 degrees. So if one SHM is here, the other SHM is here, the third SHM is here. Now what will be the resultant of all the 3? Simple. The resultant, first think of it this way. A resultant will be A I cap. Okay, don't even have to do it via vectors, guys. Don't even need vectors. First take care of these 2, this one and this one. This one and this 2 together will give you a resultant of A root 2, right? A root 2, correct? This and this together will, because they are perpendicular, will give you A root 2. Plus that A is also there. That A we have not taken care of. Now when you add these 2, what is the final resultant that you get? We'll get it as A root 2 plus A because they are in the same direction, correct? So this will be A into 1 plus root 2. That's your resultant. Is it there somewhere? Yes, option A is correct. Option A is correct. Now, that's not the only one. I think more than one option will be correct. I'll tell you what. According to the question, energy is also asked. Resultant motion is not simple harmonic. Wrong. It is SHM. No matter how many SHMs you add, it will be still SHM. Phase difference of the resultant with respect to the first is 90 degrees. No. In fact, if you compare, it is 45 degrees. So option B is also wrong. And now coming to the energy part, energy of any one SHM is going to be half K A square. The energy of the resultant SHM, energy of the resultant will be half K, this amplitude, which is A into 1 plus root 2 whole square. This will become half K A square as it is, and this square will become 1 plus root 2 square is 2 plus 2 root 2. Half K A square is nothing but E1, and this will become nothing but 3 plus 2 root 2. So the energy of the resultant SHM is the old energy into 3 plus 2 root 2 times. Hence option C is correct. Yep, A and C. Okay, very good, Anthony. I'm so glad you will do very well in life, but also I would love you to have, all the other kinds of, enjoyment that you would love to, or a kid should have at, such an engage. Please enjoy life. Don't stress too much. You are doing very good. Keep doing like this. Proud of you. Okay? Chalo. So do not forget to join our Telegram channel. The link is there in description because you will get the PDF, all updates, all important announcements, timetables, so that you do not miss any of the classes. And do not forget that if you are interested to learn from home, we have the Vedantu Pro subscriptions which are going on right now. There's a link in the description box below for 11th, for 12th, for crash courses, for droppers. Every student, you can just go down and see which course is the most suitable, and if you have any problems, do let me know in the comment section below. Thank you so much for joining in. We had a marvelous session, more than 2 hours. So I hope you had a great time. Please let me know after the video ends in the comment section below. Tomorrow I'm going to do waves, that's sound waves and waves on a string, complete revision backlog series. And if you're enjoying these sessions, do let me know. And what else you need, what are the topics you need, I need to know from you. Okay, let's do this, because it's a two-way communication. It's not whatever I feel, it's also what you feel. Okay, so take care, bacha log, take care. So glad, and have a great time. And do not forget to smash the like and the subscribe button. And yes, do recommend the channel to your friends, especially in English medium. You should be on JEE Enthuse, the only dedicated channel for JEE students. Take care. Hasta la vista. This was Captain Shreyas signing off.